Hey kids, today we're in Unit 0, which we call Introductory Concepts. And this unit is going to give you some background information to be able to do some chemistry. And today, for Unit 0, Day 1, we're going to learn two things. The first you may be familiar with already. We're going to take numbers, big and small, and report them in what's called standard and scientific notation. And then the second thing, which is probably unfamiliar to you, is we're going to learn what a significant figure is and how to calculate values in significant figures and report them. So the first thing we're going to do is talk about scientific notation. Okay, and the purpose of what's called scientific notation is to take big numbers and really small numbers and write them in a notation that's more efficient. So for example, if I had the number 3 million, okay, writing that is writing a lot of zeros. So you might want to express it in a different way. The way I wrote 3 million on the board is called standard notation, okay? I can take that number and put it in what's called scientific notation. So what you do is n would be the number, and then 10 to the a would be the exponent, or a would be the exponent, okay? So for a number like 3 million, if the number is greater than or equal to 1, you're going to move the decimal place to the left to make a number between 1 and 10. So for example, the decimal place is actually over here. You're going to count how many places you move it over. And then your new decimal place to make that number n between 1 and 10 is going to go there. So it's going to be 3, and then you write it as times 10, and then you count how many decimal places you moved it over. And in this case, you moved over 1, 2, 3, 4, 5, 6. So the exponent is going to be a positive 6. And you can see that for a big number, when the number is greater than or equal to 1, the exponent is positive. Okay? And the same thing goes if you have a little number. Okay? And in chemistry, when we talk about atoms, and we talk about electrons and neutrons and protons and things we're going to learn, they're very, very tiny. So we could have a very small number. So I could make up a very small number, let's see, with a lot of zeros in front of it. Let's just make a number like this, 0.00003. Now that's written in what's called standard notation. But if we want to write it more professionally, efficiently, we would put it in what's called scientific notation. So in this case, if the number is less than 1, we're going to take this decimal and move it to the right. Oops, one more. So we want to create a number between 1 and 10. And so we once again have our number as 3 times 10, and now we have to count how many places we moved over. 1, 2, 3, 4, 5. And because it's less than 1, the number, the exponent is actually negative. So those are two examples of how you make something in standard notation into scientific notation. So just to reiterate, note that the number is always between 1 and 10, okay, greater than 1, less than 10, and the exponent is positive if it's a number greater than or equal to 1, and it's negative if it's a number less than 1. So let's do some examples together. Let's take this number here. Now, remember, we want to take this huge number. This is called standard notation. Standard notation. We wanted to make it into scientific notation. So we have to move the decimal so that we can number between 1 and 10. So we are going to move here. That's where it's going to go. We have to count how many left we're moving it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I've moved it over 11 places. So my new number is 7.65 times 10 to the 11th. And I'm sorry about my writing. I have a cast on my right arm. So that's the number in scientific notation. Note that the exponent is positive because your original number is greater than or equal to 1. And note that the number in the spot where the actual number is between 1 and 10. Okay, now let's look at this next number. Now this number is less than 1. Okay, so now we have to move the decimal over to the right. 2, 1, 2, 1, 2, 3, 4, 5, 6. I moved it over 6 places to get that number between 1 and 10. So my number here is 4.589 times 10. Now the number is going to be negative. And let me count again. I forgot what I wrote. 10, 1, 2, 3, 4, 5, 6. Negative 6. Okay? So that is how you take standard notation and convert it to scientific notation. And you will get to do more practice with that. Oops, skip the slide. Okay, now we're in honors. Okay, so that means we have to behave like engineers and scientists, which means if your number is bigger than 10,000, okay, you should put it in scientific notation. If your number is less than 1,000, you should start putting it in scientific notation. This is just my rule of thumb. I don't really want to see huge numbers written out like this. I want to see scientific notation. 3 times 10 to the 1. 10 to the 6. I'd rather see that. Okay? So start to use scientific notation when possible for those big numbers and those small numbers. Okay, now I'm going to talk about how to use a calculator with scientific notation. Unless you're going to use parentheses, the way to put it in your calculator, if you have a TI-84 graphing calculator, you are going to, if you wanted to type in the number 3 times 10 to the 8. In your graphing calculator, you type it as 3, then you find the button that says second, and then you find the button that says double E, and then you type the number 8. This is a great way to use your calculator for scientific notation instead of having to write parentheses. If your calculator is not a graphing calculator, or it's a scientific calculator without the graphing, you may have to use the EXP function. So you would type 3, find the EXP button, and then put in the number 8. So the red is for if you have like the TI-84 graphing calculator, how to put in scientific notation. The blue is for a standard scientific calculator like the ones that are given out in my class if you're back at school. Okay, and if this confuses you, see your teacher for more help on Zoom. Okay, also another way to do it, but if you do it this way, you must use parentheses, is to do what's called I call it a caret. And you put that little caret. But if you do it this way, you must use parentheses. And I don't recommend it because people forget parentheses. Okay, so you write 3 times 10 caret 8. Okay? Okay, next topic is called significant figures. Okay, so these are just numbers that show the precision of an instrument a chemist is using. So as an example, look at these two scales, okay? And if you look at the numbers they give, one is 34.699 grams, one is 34.7191 grams. And you can see that the one on the right, scale number 2, goes out to one more place setting than scale number 1. So if you had to pick which scale would be more precise, I would hope you would choose number 2, since it has more decimal places that it goes out to. So since in chemistry, we use a lot of pieces of equipment that have precision, different precision, we need to be able to reflect that in numbers. So we call those numbers significant figures. Okay, and I have narrowed it down to having 3 rules for significant figures. Okay, so for example, if a number is significant, it is always a non-zero. So if we go back to the scale on the other page, 34.699 on scale 1. All of those numbers are significant. So you would say this is 5, and I always abbreviate SF for significant. 5 significant figures. They're all non-zero numbers. So that's rule number 1. So 225.3, as an example, has 4 significant figures. Every one of those numbers is significant. It represents the value. Okay, rule number 2, any zeros between 2 significant digits are significant. So what that means is I call this the sandwich rule. If you have a 0 between 2 significant digits, it's significant. Well, we already know non-zero is significant. So what if I had a number like 201? Well, since this 0 is sandwiched between 2 significant digits, that must be significant as well. So that means this also, or excuse me, this has 3 significant figures. And in the end, the last rule, a final 0 or a trailing zero in the decimal point are also significant. So if you have a 0 to the right of the decimal point, or a final 0 or trailing at the end, and they're in the decimal part, they are significant as well. So for example, if I had the number 121.200, these zeros are trailing at the end after the decimal, which means they are significant. So in this case, this number would have 1, 2, 3, 4, 5, 6 significant figures. Okay? So let's review the rules again. Non-zero digits are always significant. That means zeros are insignificant. Okay? However, look at rules 2 and 3. Zeros are significant if they are between 2 significant digits, or they are significant if they trail in the right side of the decimal. If they're trailing zeros or final zeros in the right side, they are significant. Okay, and here you can look and see this example down here is a very good example of trailing zeros, sandwich zeros, and non-zeros. So let's do some examples together. Okay, Why don't you pause the video and see if you can figure it out on your own. Okay. So A, let's figure out how many significant figures there are, and then we got to justify which rule it tells. Well, 50.50, we already know fives are non-zeros, so they're significant. If we look at the middle zero, we know that this one is sandwiched between two significant, so that's significant. And then our last zero is a final zero at the very end to the right of the decimal. So in this case, we have 4 significant figures. In the next one, okay, remember one thing to emphasize, there's only 2 ways zeros are significant. If they're trailing or final after the decimal point, or they're sandwiched between they're sandwiched between significant digits. In this case, we have an 8, which is always significant, and a final 0 to the right of the decimal. Those are significant. In the case of the zeros here, they are not significant because they are not sandwiched and they are not trailing. Since they're not trailing or is not sandwiched, those 3 are insignificant, leaving you with only 2 significant figures here. And in this problem here, you have a final 0 and a sandwiched 0, so you have 5 significant figures there. And you only look at the number that you ignore the exponent for this problem. Okay. Okay, now we're going to talk about how to use significant figures with math. Okay, so now we got to take what we know about significant figures and figure out how to do math with them and get the answer in the appropriate significant figures. Okay, multiplication and division is a lot easier than the addition and subtraction. So let's read the rules together and then we'll do some example problems. In multiplication and division, when you look at the product, you are counting the same number of sig figs as the least number as one of the terms you're multiplying. Okay, so in multiplication and division, the final answer contains only as many digits as the least accurate term. Okay, so for example, let's look at this problem here. You have 0.0305 centimeters times 12.556 centimeters. Okay, you do the math in your calculator and you get this big long answer. Okay, well, you got to report it to the right number of significant figures. So if you look at the first term, you count how many sig figs the first term has. Okay, and the first term has, okay, the 0.0 is not significant, but the 0 sandwiched between the 3 and the 5 is, so the first term has 3 and the second one has 5. You look at the smaller number, and 3 is smaller than 5, so you represent the answer in 3 significant figures. Now, you got to remember when you cut it to those 3 significant figures, you need to look at the next number to see if you have to round up or down. And since 9 is greater than or equal to 5, you take that 2 and round it to a 3, making it 0.383. Okay? So in multiplication and division, you're just counting each thing you're multiplying or dividing, counting the number of sig figs, and whatever's the lowest number, which happened to be 3 in this case, you make the answer that number of sig figs. Okay, now for addition and subtraction, it's a different rule. You're not counting sig figs. The final answer has to have as many digits as the least accurate term with respect to the position of sig figs around the decimal. Okay, so let's look at this problem here. You are adding up these three numbers. Okay, if you look at it, these numbers, when you add them up, this is the answer I underlined in purple is what you get when you add them all up in your calculator. Okay, so that's what you get when you add them all up. But we got to take into account significant figures. Okay, and you're looking with respect to the decimal place. So if I look at the first term, this goes out pretty far, right? It goes out to the tens, hundreds, thousands, 10,000s, 100,000th place. Pretty accurate. You look at the next number and it only goes out to the 100th place. You look at the next term and it just goes to the ones. Okay, so the least accurate term with respect to the decimal is going to be this 3. So what you're going to do is round to that ones place, making it 1226. Okay, so let me repeat that again. You are rounding to the least accurate term with respect to the decimal. Okay, now it's important to keep these two rules separate in your head. There are two different sets of rules. Multiplication and division is one, addition and subtraction is the other. Okay, so let's do an example problem here. Okay, consider this problem. Okay, 0.10345 plus 23.34 plus 1203. Okay, now I put the answer on the bottom. See if you can get that same answer. Pause it and see if you can get the same answer. Okay, let's do it together. Okay, so the first thing you're going to do is just add it up in your calculator or by hand and see what you get. Okay, so when you add it up in your calculator, you're going to get the answer I write out in blue. 1226.44345. Okay, this should be a 3 here. Okay, so now what we have to do, since we know we're doing addition, we've got to look at addition rules. So now I'm going to round to the least accurate term. So what I'm doing is underlining that last significant figure around the decimal for each of the numbers. And the least accurate term is going to be this one here, and that number 3, which is in the ones place. So I'm going to cut it off right there at that ones place, making my answer, my final answer, 1226. Okay. Now here's another problem we can do together. Okay, now we do have parentheses, so we could do the numbers in parentheses first and make sure we round to the appropriate sig fig. So the first thing, we'll do this side in purple, and when I do it in my calculator, I get 53.964. Okay, now looking at addition and subtraction rules, I have to look at the least accurate term with respect to decimal. And in this case, it's going to be the hundredths place with this 4, so I've got to round to the hundredths place. So my final answer for the purple part is going to be 53.96. Okay, now I'm going to do the second part in blue. So I'm going to take my calculator and subtract, and I get 36.208 right from my calculator. And now I got to look at my last accurate digit with respect to that decimal, and it's got to be the hundredths place again, which is this place. Now I got to look to that next number, and since that next number is an 8, I got to round appropriately, so it's going to be 36.21. And now I've got to take both these numbers and add them together, and I get 53.96 plus 36.21, and I get an answer of 90.17. And let me check my number of sig figs. This goes to the hundredths place. This goes to the hundredths place. So I am already rounded to the hundredths place. So this is my final answer. Okay. Okay, here's a multiplication one to practice together. Okay, we've got now multiplication. Remember, you're not looking at the least accurate term with respect to the decimal, you're just counting sig figs. Okay, so the first thing I'm going to do is put these numbers in my calculator, and I'm going to get an answer. And I get a big answer like 32.573982, blah, blah, blah. Okay? Now I'm going to count significant figures. Okay, so if I count the first one, it has 5. I count the second one, it has 3. And if I count the third one, 1, 2, 3, 4, 5, 6, 7, 8. Okay, my lowest number here is 3, so I need to round this to 3 significant figures. Okay, and when you round, you got to keep the gist of the number, so you got to take the big part of the number. Okay, but this is a 7, so I got to make sure that rounds up to a 6. So my final answer is going to be 32.6. And that's how you do multiplication. Okay, so that's it for the practice video. We're going to do more in class tomorrow with some practice. Okay, so I hope you learned a lot about scientific notation, standard notation, and significant figures. Thanks.